Well, thanks for having me, Emrah, once again, and nice to see you all. And today we are going to talk about Gen AI on AWS and how we can use Gen AI on AWS. And we will be drawing back from our experience, deploying real Gen AI solutions in the past year and a half. About me, I'm Ersel. I'm co-founder at CMND. We built a platform as a service solution for Gen AI applications. So you can, build your assistants, autonomous agents with ease. So let's begin. So what is Gen AI? Lots of people are talking about Gen AI, and obviously you have heard about the term. Well, it's an umbrella term for, suite of machine learning models, and like these can be LLMs, could be like image generation models, like DALL-E, Midjourney, and all these algorithms rely on GPUs. That's why this Taiwanese gentleman on the right-hand side is probably the most important man alive at the moment on Earth, Jensen Huang, the founder of NVIDIA. So, and when we say LLM, what do we really mean? An LLM is, as we said, is an algorithm that, predicts the next word. If you think about this sentence, weather report is going to, it says it's going to rain tomorrow, I should bring and if you fill in the gaps, it's obvious you should say umbrella. And that's, the main technique behind an LLM. So it's trying to predict the next token. And instead of humans, LLMs think of things, we say tokens. If you, put a sentence into tick token or OpenAI's token generation algorithm, you will see on average like 4 or 5 letters is a token. That's what LLMs call a token. Okay, and this is very important. So the main pain points when you are deploying Gen AI applications tend to be, the underlying models are stateless, and the GPUs are quite expensive to buy or to rent. And we also have limitations with context window, how much working memory an LLM can effectively work on at any given time. And last but not the least, hallucinations, the tendency of LLM or Gen AI models to make mistakes or to get confused about what they are working on, right? And, we have some solutions to, manage these pain points. So we will start with the biggest problem. GPUs are expensive, so is Gen AI. So if you look at the trajectory of main LLM models over the past 3-4 years, there is this tendency that the LLM models are getting bigger in terms of training size, parameter size, and that means that to run a state-of-the-art LLM model, you need ever bigger GPU capacity, and that will that's because of that reason, it's more costlier to run the state-of-the-art models. And, if you are not orchestrating your infrastructure in a, well-thought manner, that means you are wasting, money on your infrastructure. So what can we do to keep the Gen AI costs under control? The obvious solution is to, instead of buying or instead of going down the costly on-prem solutions, you can start using cloud-based inference providers, such as AWS Bedrock, which was introduced recently, and it gives you access to many, many models off the shelf, including those from Anthropic, and also open source alternatives like Llama. And we also have a Turkish, not Turkish company, but a company founded by Turkish people, Fal AI. They have been making the waves recently because they are the main cloud inference provider for image and video generation algorithms. Again, a very, very good model. So on average, I would say renting is the smartest approach. if you are getting started with Gen AI applications, instead of buying GPUs upfront. But there are some problems if you are working in regulated industries. Unfortunately, in Turkish market, these cloud-based inference providers might not be the right candidate for you, and I think that's a big major blocker for adoption in Turkey in like finance, insurance, healthcare industries. So, but if you are not dealing with those kind of use cases, definitely the cloud inference is the way to go. Now, another thing that you should be proactively doing is to keeping track of the costs, the token usage of your assistants and agents. And the way to do this is to, keep track of all the input and output tokens that your systems are exchanging with inference providers, and also keep track of the cost metrics of individual models, like how much does it cost us to use, let's say, GPT-4o, how much does it cost us to use Anthropic 3, so Cloud 3.5 or 3. Whatever, so that you can see the actual cost of your interactions day by day and take action accordingly. And in that light, I would also advocate using a middleware. So instead of talking directly to AWS Bedrock or OpenAI APIs, use middlewares that allows you to switch between different providers and models at any one time. And there are, some solutions out in the market for doing this, so that when you, ask a question to an LLM, the middleware layer can choose the appropriate service provider, like OpenAI, Anthropic, whatever, and then use that inference provider, depending on the problem. So we built something like this internally called LLM proxy. If you are using JavaScript, you can find it on NPM and start using it directly. Another similar architecture is also available by Versal, the people who develop Next.js. You can also check it out. So I will definitely recommend getting up and running with a middleware before talking directly to an inference provider. Okay. So another thing that you can do proactively is to use services like AWS Batch or AWS Fargate if you have processes that require GPU instances. So as you know, Lambda doesn't have GPU support at the moment. So AWS Batch is a much better alternative if you want to do vector ingestion or inference provider type of work on AWS right now. And when you are getting up and running or getting started, it's much cost effective than renting or a EC2 instance out of the box. Okay. So the second problem with Gen AI or LLMs in particular is that the models currently are stateless. So you give it some input, you get output, but there's no storage mechanism built in. So each message that you exchange with the inference provider, you need to keep track of the storage, like what was the messages, what were the conversation that we had. So in this sense, there's a lot of options on AWS for long-term storage. We use a combination between S3 and RDS in our use cases, which was working quite well for us. And if you are thinking of doing some post-processing in a NoSQL sense, DynamoDB could be a good option for you as well. Right. Okay, and as you keep track of your conversations, at some point you will have a problem called the context window limit, right? So a human brain can only, keep, up to certain digits in their memory, in their working memory. Same problem exists in the LLMs as well. So they have a working memory, which we call the context window limit. And if you keep exchanging these messages, the context window limit gets full, right? And when this context window gets full, the LLM is more likely to make mistakes or hallucinate some more. So you have this problem if you have too much garbage in your context history, the output will degrade over time as well, right? And there are a few solutions that we can use to keep this problem in check. And probably the most popular one on the scene right now is the RAG systems, retrieval augmented generation. It's a very simple concept that you get, let's say, all your previous messages, all your corporate knowledge bases like PDF files, Excel files, Word files, and ingest them into a vector, something we call a vector database. And depending on the user query, you are getting the most relevant chunks of information and feeding into the assistant to get a good response from the LLM. And what we mean by vector databases is actually a simple idea, but a very smart idea, is that if you have text pieces of Word in your document, you split them into like little chunks, and then you use what we call a vector algorithm to represent these concepts on a vector space. And the idea is, if you have, the word dog in your system, the word cat is somehow related to this word, right? It's like it's a pet, it's an animal. And in the same way, if you have apple, we know that it's related to a banana. So this way, if you are doing a vector search, it performs better than just doing a simple string search, because now you are searching for the semantic meaning of those sentences so that it's helping your LLM assistant to respond better, more grounded. And here, we have a very simple solution that you can use on Amazon ecosystem. And you can get up and running by using Postgres and installing the PG Vector plugin on your Postgres instance. And once you start chunking and embedding your vectors, you can also use a very smart algorithm, HNSW algorithm, to index your vectors, which means you can do vector searches across millions of documents with pretty easily. Okay. The other problem is the memory strategy in the classic sense. So if you have used ChatGPT recently, you realize they used to have a memory limit, they were using only 100 pieces of active memory. Now they have something called long-term memory, which is a similar concept. So you have all the users' past conversations, you store them on S3, you run it through an embedding model, and then you end up all these conversations in vectorized form in your long-term memory, so that as the user is keeping conserving with the agents, you can still keep referencing the old messages and relevant pieces of history from their context. So, and this becomes a very strong customer retention strategy, really, because now that you can refer back to all the previous discussion points you had. Okay. Now, hallucinations. This is the hard problem to solve. So, and there's no one magic silver bullet to really fix it for you. But you can combine a few strategies here. So the first thing that you should really think of doing properly is writing detailed prompts. So many people skip that step. They think, with a very short, maybe like system prompt, they can give their assistants, agents a good persona. But that's not enough. If you look for the default system prompts for some of the leading LLMs out there, it's actually quite detailed. They explain what tools are available to the agent at any one time, and in what scenarios, how it should behave, what it should do, and what it shouldn't do. So you should think of, when you are writing your prompts, you should think of all these scenarios, okay? What's the persona, what it is supposed to do, what it shouldn't do is quite important as well. So that's one, that's a fundamental step you should never skip. And secondly, as we see before, you need to expand the chatbot with a very good RAG system. Make sure you feed it the right data, the right documents, so that the answers are grounded in reality and truth. And if, after doing these 2 steps, you are still getting hallucinations and the performance is not up to par, you can consider switching to a better model or a bigger model. So, and as you might know, like in some tasks, some LLMs are better than others. Like for example, Cloud Anthropic is much better at the software side of things, whereas ChatGPT or GPT like algorithms are better at some other tasks. So you can mix and match. So for some assistants or for some workflows, you can try Anthropic. For some other, maybe you try Llama. You might get better performance and better results that way. And maybe a bit of a controversial point, I don't believe in fine-tuning that much. Why? I think it's most of the time is a waste of effort from development perspective, because if you are not capable of getting, let's say, 80–90% of the results using the base foundation models, extra fine-tuning, I don't believe that it will give you the right level of correctness that you are trying to get from the system. So there is this big, scary story by Bloomberg. So they spent $10 million fine-tuning and developing a financial language model. And after they finish the development, they make a success PR story about it, whatever. After 6 months or so, GPT comes with a new model, and they can already surpass their fine-tuned, custom model just by out of the box. So, yeah, I would be cautious when proposing fine-tuning or this kind of solutions. Whether you should try solve the problem with one of the first 3 considerations, and as a last resort, maybe think of fine-tuning. Okay. Now, tools, you might have heard, and MCP protocol is making all the waves on the social media nowadays. These are all the same concepts. So when people say tools or MCP servers, what they really mean is just the API built for large language models to be consumed by the API, for the AI. And these tools, it could be things like, talking to a third-party system, creating a file on the file system, reading a file on the file system, and all these kind of actions. So in that scenario, we think the best way to model this behavior is using things like small Lambda functions, which are isolated. They run on demand, whether you have some job to do, depending on the workflow. And let's continue. And the thing to be very careful when you are introducing tools and MCP servers to your LLMs is that you need MCP servers or the LLMs by design. They don't care about the authentication mechanism, privilege mechanism on the systems. So, what we did in most of our deployments is that we introduce RBAC checks, role-based authorization checks, similar to AWS IAM, so that LLM can only leverage tools that it has access or permission to, okay? And never delegate this kind of permission logic to the LLM. So don't put in the system prompt, you are not allowed to use this. It will, it will hallucinate and try to use it. So never try to do that. Instead, do that check in the code level if it's authorized. And you can also consider using AWS Bedrock guardrails system, which keeps the LLM output in check so it can filter sensitive content. Okay. And this is our current system for our, assistants. So we have user message coming in. We embed the user's input, and then we look at the past conversations that we have, and do a, vector query search, and we insert that relevant context to the LLM's context window. And we have our LLM proxy here, which is responsible for making the tool calls on the Lambda, if necessary. And after all these checks are done, we are filtering the output with AWS Bedrock guardrail to make sure we are not giving sensitive data or malicious data to anyone. And then, only then, we are responding back to the user in return. So, you can see it there, okay. And, well, that was, our, main learnings over the past 16 months of developing Gen AI applications. And, we are looking for partners to, look into particular use cases in particular industries. So if you are exploring AI transformation or this kind of activities, we will be happy to chat and connect. And you can find me on these social platforms. And also, you can also check our website at cmnd.ai. And thanks for your attention.
Thank you so much, Arslan. So, learning from the tools available is something, but learning from the real experience is really valuable for us. So it was great to listen to your talk. Is there any question that for Arslan? We have a couple of minutes. And yeah, there's one.
Thank you. Thanks, Arslan, for the presentation. It was awesome. So just a quick question on caching some frequent queries. So do you think is it logical to cache some frequent queries or completions to avoid redundant calls? What do you suggest with that?
I mean, yeah, in terms of caching mechanisms, we, in CMND architecture, when we make a tool call and we get some response, we also include the tool response in our long-term database. So it's kind of keep learning from, running tools and looking into our existing knowledge bases. So yes, definitely, it makes sense to introduce some caching there. Or you can also introduce some caching at your MCP server level if you are doing a very expensive operation there. But out of the box, I would say you wouldn't need a cache layer here unless you are doing something really expensive.
Got it. Okay, thank you.
Any more questions? Okay. Thanks a lot, everyone.
Thank you.
Thank you, Arslan.
Thank you.
And take this as a gift.
Oh, thank you.